Good morning, everyone. Welcome to the CABE webinar Wednesday for Wednesday, the 2nd of February. As most of you will know by now, my name is Jordan. We are joined this morning by Dr. Tony Hopkin. And as you can see on my screen, we're going to be discussing new build housing defects. Already mentioned this, I'm Jordan. I will be the moderator today, so I will be sat in the background just making sure that everything runs smoothly. As always, please feel free to send in questions or comments. If you're joining us live via Zoom, you can do that via the chat or the Q&A panel that will appear up on your screen. If you are watching this back on YouTube, feel free to send any questions through to webinars@cbld.com. And of course, you can tweet us using the hashtag CABECPD as well. So, as mentioned, your presenter this morning is Dr. Tony Hopkin, who is Head of Construction and Quality at Midland Hart. So, Tony is a chartered engineer, chartered construction manager, chartered building engineer, a fellow of CABE, as well as the Chartered Institute of Building. He has held roles at academic institutions, a contractor, a warranty provider and building control body, and a housing association as a researcher, lecturer, general manager, consultant, and currently as head of construction and quality at Midland Hart. Tony has a keen interest in quality and has a doctorate in defects. He's published on the subject of construction quality in leading journals, industry publications, and has spoken at both national and international conferences. In addition to this, Tony provides CPD seminars for professional bodies, evidence of that here this morning. He is also a peer reviewer for journals, undertakes interviews for professional bodies, is a British Standards Institution committee member, also a member of CABE's Membership Professional Standards Committee, and sits on a number of industry groups. Hopefully that gives you a little bit of a background to Dr. Tony Hopkin this morning. With that, I'm going to ask Tony if he would like to begin sharing his screen and take you through his presentation.
Cool, thank you. Yes, I will share my screen. And yeah, the only way is down from that sort of introduction. So thank you for that. I was going to say, it says I can't start my screen whilst you're sharing yours, so I need you to stop. Cool, thank you. Right, there we go. Splendid. So hopefully everybody can see that. So yes, I'm Tony Hopkin, Head of Construction, Quality and Innovation at Midland Hart Housing Association. And this session will last probably 45 minutes, and it's looking at new build housing defects. So just a bit of an overview of the session. So we're going to start with who Midland Hart are, because I'm just conscious that the majority of people on the session today won't be familiar with us and what we do. Then go into a bit of an overview of defects and quality and the general perception of quality in the house building industry. Then look at some Midland Hart based stats, so some common defects, both during construction and also during various post-completion phases. Then going to look at a bit of research that I've done previously with De Montfort University into the underlying causes of defects. And then we'll get into the probably most interesting bit, where we'll go into sort of a detailed dive into some prevalent defects and try and map those to some underlying causes to kind of just not just focus on the end product, but focus as to kind of why it's happened. And then we'll close the session with a bit of research that was done with the University of Reading that looked at how we can learn from defects and implement various strategies to reduce them. Okay, cool. So Midland Hart, we are a leading Midlands-based housing association, and we own and manage roughly 33,000 homes for more than 70,000 different customers. We do develop properties as well. So as part of our corporate plan to deliver 4,000 homes between 2019 and 2025, we deliver roughly 650 homes per year. And the homes that we develop are predominantly for affordable rent and shared ownership. In the past, we have done some private rent and some private sale, but the bread and butter of what we do is the affordable side of things. So quality, it's a very subjective topic, but I look at it in a really very simplistic view. So for me, quality, it's not the fuzzy sort of stuff that goes on. It's the more the way I see it's almost more compliance. So it's things like complying with your warranty provider standards and requirements, depending on which warranty provider that is, complying with regulations and following whatever guidance you need to in order to comply with that regulation. And then as somebody who's more often than not an employer under a construction contract, it's complying with our employer's requirements and the specifications that we use or are the basis of the builds that we do. So when I talk about quality, I talk about compliance. So when I talk about defects or note any defects in any stats or reports or anything, it's something that either doesn't comply with the warranty provider standards, doesn't comply with the building regulations, or doesn't comply with our employer's requirements, or something that doesn't comply with any of them. So a very simple yes, no sort of view. So now just moving on to sort of the public perception of the house building industry. So what's quality like in house building? If you search housing quality or poor housing quality or new build housing defects, you get a ton of articles and you get lovely headlines like this. So why is most new build housing in Britain is awful? Again, probably about as bad as the grammar on there, and why it doesn't have to be this way. Second one is first time buyer couple are still battling to get big builder to fix a dozen problems with their £200,000 new build home a year after moving in. And then the third hit on there was just our new build nightmares. Many new homes have dozens of defects, and as these owners reveal, trying to fix them can be a costly horror story. So basically that says to me that if you're looking at kind of the public view or the general view of the house building industry and quality, it's not particularly good. There's a negative perception of our industry, and there's a suggestion that none of us care about quality and that what we produce is pretty much slapdash, just trying to do what we can as quickly as we can without concern for the level of quality that we hand over. Just taking that a level further, there's some data out there, and probably the easiest one to go to was the HBF's customer satisfaction survey. And there's a couple of pretty important questions in there with regards to quality. And just on this, I am using defects as a proxy for quality because of the simplistic view I'm taking. And one of the questions in there is, have you reported any problems with your home, i.e. defects and snags, to your builder since you moved in? And these are the results of the 8-week survey. So within 8 weeks of moving in, 94% of people who bought a property reported a defect to their builder. Taking that a bit further to try and quantify the number of defects, there's a follow-up question that asks approximately how many problems have you reported to your builder? And 31% of that 94% have reported at least one, so between 1 and 5. 28% reported between 6 and 10. 16% reported 11 to 15, and then a quarter of them reported 16 plus. So what we can do very simplistically is generate a view of the number of defects that are reported in the industry during that 8-week period. So during the survey period, the year before, there were roughly 175,000 completions of homes. So 94% of that is 165,000 people have reported a defect in their home, assuming everything being equal. And then you take the best case scenario of that approximately how many question. So 31% of 165,000 reported 1, 28% of that 165,000 reported 6, 16% reported 11, 25% reported 16. That gives you roughly 1.25 million defects reported across those 175,000 homes within the first 8 weeks of people moving in. And that equates to roughly 7 defects per unit. So again, it's a relatively large figure in my view. And again, it's also worth noting that that is 8 weeks. But again, based on this survey, they might not be necessarily genuine defects. They might just be wider problems. But at Midland Heart, we do analyse defects, and we look at our defects per unit on a monthly basis. And we pretty much analyse it for all schemes that are in the defects period under the contract, so those that were within the first 12 months. And our defects per unit at the moment sits at 1.8. So again, for the entire year, on average, our homes have 1.8 defects in them. And that's because we have sort of 3 or 4 additional layers of quality assurance. So in addition to the builder's quality assurance, the warranty provider inspecting, the building control body inspecting. We also have clerk of works who go out on a weekly basis and inspect sites. We have what are called employers agents, who again will periodically go out and inspect sites and pick things up. We have some internal quality inspectors who again do the same sort of thing. And then we have some internal project managers who will visit site, and also they'll snag the properties before we take handover. So probably picking up a lot of the things that the private buyers are kind of identifying within that 94%. But it is worth noting that there's lots of good work going on in the house building industry. So we've seen things like warranty providers implementing new strategies with regards to quality assurance. We've seen house builders bringing in things like quality inspectors, and stuff like that. So there is a lot of focus going on, and it's also worth noting that that 94% of have you reported any problems to your builder since you moved in has gone down in recent years. So it was either last year or the year before, it was at about 99%. So again, we're seeing a movement in the right direction. So I'm not just saying everything is bad, that the industry is bad, and I'm not saying that that's the view, or the view of the general the general perception is correct. But again, just reporting on what's there. So now moving on to common defects. So these are some Midland Heart statistics. So as I've said before, we develop roughly 650 homes per year with multiple developers and contractors across the region. And if this was a survey, then based on roughly 175,000 completions, then a 650 sample would give you a confidence level of about 99%. So again, we're pretty sure that what we're reporting is indicative of what's going on in the wider industry, and a margin of error of about 5%. So it suggests that our sample is representative of the wider industry. And when talking about stats and common defects, there's three, for me anyway, three distinct phases that you break it down into. So pretty much during construction or pre-handover. So any sort of design issues, anything you see on site, anything you actually pick up before the property is handed over. Then you've got the 1 to 2 years post completion, so during the defects liability period or the builder's liability period, depending on whether it's under your construction contract or your warranty. And then again, depending on kind of your involvement in the building in later life, it's either your warranty period, or for us as a housing association who manages the stock, it's the repair period. And you tend to see some slightly different things during these various stages, which I'll touch on in a bit more detail later. So during construction, this is a breakdown of our clerk of works inspections. So they'll go out, as I've said before, on a weekly basis, record any things that they see that are incorrect, categorize them. And this breakdown is based on roughly 2,000 inspections per year. So 57% of what we see relates to superstructure. The second biggest area is to do with external works. And then the third area, again, you have to forgive the categorization, it's a bit ad hoc, is to do with internal walls. And to break that down into a bit more detail, so superstructure wise, the bulk of what the clerk of works pick up to do with cavities and insulation. So these are things like dirty cavities, gaps in insulation, all sorts of stuff like that. And then the second largest area is to do with damp proof courses and cavity trays. So more cavity trays than anything. And again, it's cavity trays either being in the incorrect position, not being formed correctly, being dirty, being damaged, whole host of issues. And then just another one that's not as prominent, but again, worth noting, is that they pick up certain issues with cavity barriers. And again, that's things like them either being absent during the inspection, not being installed correctly, there being gaps and things like that. But again, it's just worth noting these are things that are picked up and are rectified before the actual property is handed over. Onto external works, well, pretty much everything that is picked up under this category relates to access to the building. And again, that might just be because that's what the clerk of works look for. So again, all of these inspections, and any inspection really, is slightly biased by the preference of the person looking at things. So I'm not necessarily saying that access is a massive issue, but it is for us, and it's something that feeds back through our reports. And then finally, internal walls. bulk of the issues to do with plaster and plasterboard, and it's largely the installation of plasterboard, so it's not being installed correctly. Second biggest issue is to do with architraves not being installed correctly, and again, this is things like gaps behind them or them not being fixed properly, so just being tacked, for example. So during the defects period, so this is our entire 12 months post completion, where we take the property, moves over, resident lives in it, and then pretty much any defect they find, they report back to us. And we, at a defects per unit of about 1.8 from 650 homes, that's roughly 1,100 defects per year that come through to us. And again, our breakdown is slightly interesting. So again, the largest issue that we face is to do with plumbing, and it's very simply to do with leaks. So it's somebody moves into a property, they have a bath for the first time, they let all the water out and then it leaks. And this is a relatively common issue. So leaks are one of our biggest issues. Okay, second largest issue is to do with electrics, so 19% of what we see. And again, that's to do with things like sockets not working or switches not working. And again, as I'll touch on in a minute, these two issues largely feed on through our assets data as well. Okay, now during the repair period, again, these are repairs for properties that are sort of in the 10-year window post completion. So we're not looking at sort of historic properties here. And this is from about 40,000 repair records. And the biggest issue during this period for us, it's still plumbing. So from a plumbing perspective, just to pick out a few of the comments on the jobs that were raised for contractors, like leaking cold tap in the bathroom, uncontainable leak from the toilet, watermarks on the living room ceiling with the bathroom above it. So again, it just follows through from what's been reported during the defects liability period. Second biggest issues to do with carpentry, more specifically doors and windows, based on the comments that we're seeing. So 23% of our 40,000 repairs related to that issue. And just to give you a flavour of what's going on, so things like the back door sticking, it's hard to open, the front living room windows jammed shut and it won't open, the front door's dropped and it's difficult to open and close, that should say. So yeah, it's largely to do with doors and windows more than anything, and I think that's probably a relatively prevalent issue across the board. And then finally, the third biggest area, again, these make up the bulk of what we're looking at to do with electrics. And again, it continues down the sort of same line of things not working properly. So that's things like sockets upstairs or in the living room not working, the light switch in the bedroom's not turning on, and it's not because the bulb's blown. The hallway light won't switch off, irrespective of what you do with the switch. So again, it's just things not working as they should do. So that's just a summary of the common problems, and then after this next couple of slides, I'll go into some detail of those and what they look like and what their causes might be. So moving on to underlying causes, what we see on the face of it is the symptom. So basically the electrical issue is the symptom, but in order to eradicate them properly, we need to really understand the underlying causes of, forgive me for having disease, but of the problem. So basically the symptoms, the tip of the iceberg, the underlying cause is the rest of it. And with De Montfort, did some research with a student there looking at the underlying causes, and we analysed 5,000 defects records where the inspectors pretty much offered some ideas as to what the underlying causes might be. And pretty much this is the breakdown of them. So the largest area in those records was to do with a lack of skills, knowledge and poor workmanship. Is likely to be the largest because it has kind of grouped three pretty different areas, or relatively related, but three pretty large areas together. So that's 19% of that 5,000. Second largest area of 18% was to do with management and supervision. So these were things like trades not being supervised properly, or site managers, for example, not having enough time to go out and and do inspections and things like that. Third biggest issue, 17%, was to do with quality control. So again, these were things like quality processes either being not in place, so no formal quality control process in place, or quality control processes not being followed, or one of probably the more interesting ones is that there's a quality control process in place, but it only kind of works in certain situations, so it's not extensive enough to cover what it should do, so it's falling down. Fourth biggest, so 10%, was to do with design, so design defects, so areas that have been designed whether the design's been incorrect. And then we got things like program demand. So as I'm sure anybody in the house building industry will understand, is there are certain times of year where you're being kind of pushed and pulled in all directions to make sure you meet handover targets. And there are times where quality will suffer as a result because your focus is on a handover, for example. So it's either things are missed on those plots when taking handover, or pretty much plots that are in an earlier stage of production are given less attention than they would have been if you weren't kind of focusing on the ones that you were due to hand over. I hope that makes sense. Another one is communication and responsibility. So there's a lack of clarity over who should be doing what. And that kind of links in with another one, which is availability of information, where we kind of found that information wasn't being given in the right format to people who needed it, and it was either being kept on a system or in a site cabin, for example. And then we did a load of follow-up interviews with key people involved in quality. So we spoke to Clerker Works, designers, developers, housing associations, warranty providers, building control bodies, to try and just get an idea of whether these figures were right, and generally the perception was that they were, and also try and explore why these might be the case. So why was there a lack of management or supervision? It was things like site managers having to do 101 jobs, so they didn't really get time to go and walk the site every day as they would want to. With regards to sort of lack of skills, knowledge and poor workmanship, again, there was a suggestion from a lot of the people that there's a lack of apprenticeships, there's a lack of desire for young people to come into the house building industry. So with an aging workforce, this is kind of perpetuating the problem. And then there was kind of on a design perspective, there was the view that a lot of designers don't get out on site anymore like they would have done historically. So they kind of lack that exposure to understand whether certain details are not actually work in reality. So again, there's a whole host of things, and it was quite interesting. But what this does is it gives us an idea of what some of those underlying causes are, and then when I go through some of the more kind of prominent defects, I'll try and map some of those to those underlying causes as best I can. So now we're going to do that. So we're going to look at examples of defects. So we're going to look at cavity trays, which are one of the biggest problems for us during construction. Again, on a construction perspective, we're going to look at cavities and insulation, so common problems there. And then a less common problem, but an equally important one, so issues with cavity barriers, and I've also lumped fire stopping in there as well, just because it's a relatively interesting underlying cause on some of these ones. And then again, another sort of construction problem, the installation of plasterboard, and similarly with access to the actual building itself. And then our most common problems during the defects period, and also the sort of repair period, where we look at some issues or an issue to do with plumbing and also electrics, and map those to some underlying causes. So basically, this is a picture of a cavity tray installation at a stepped abutment. So probably the earliest thought is that, okay, it's not right, it's just installed incorrectly. But if you start to think about it and go into it in some detail, it's actually quite interesting as to why it's not been installed correctly. So it's this area here for anybody who couldn't see that on the screen. And what's happening on site is we've got this bungalow here at plot 16, and we've got it abutting these two semi-detached two-storey houses at plots 17 and 18. and again, we don't need to dwell on that too much, but this is the level of information that was available on site. So these were the actual drawings that were provided. So there's minimal information on them. As you can see, there's nothing to tell you what actual pitch the roofs are meant to be. So what I'm trying to say is that these particular plots had two different roof pitches. So the bungalow had a 33-degree roof pitch. The two-story house had a 39-degree roof pitch. And there were 5 plots on that site with 33-degree roof pitch. There were 55 plots with a 39-degree roof pitch, and these 3 units were due for handover on the same day, and the others were completed on site already, because these are lagged behind. So basically, good practice suggests that you use a template such as a roof truss or frame with guidelines to assist with setting out step trays. And my view is that's what the bricklayers did. But I don't think they actually used the right truss, for example. So if you look at this here, so the purple line is the 39-degree roof pitch. And if you follow that 39-degree roof pitch, you're somewhere near right on the position of the cavity tray. Again, it's not right there and there. But again, they followed the general line. But as I've mentioned before, this is a 33-degree roof on the bungalows. So what I suspect has happened is the bricklayers used a truss to set out the tray, but they've used the wrong one, because again, on those drawings, there's nothing to say that there's 2 different roof pitches. And I don't know, maybe some of you are better than me, but I couldn't really tell the difference just by looking at a truss, whether, if I did know, for example, whether there were 2 different roof pitches. Not obviously anyway, not where they're stored. So yeah, I suspect that what's happened here is they've used the incorrect truss. They've gone and tried to do what they should have done. Yes, granted, there's a bit of workmanship here where that's not right and that's not right. But ultimately, they've had a relatively decent go at it, and it's probably, in my view, the lack of information and the lack of understanding of the 2 different roof pitches that has actually contributed to this issue. So I'd say it could be kind of botched to make it work slightly, but you've still got that issue down there where you're essentially going to have cavity trays that are actually directing water into the bungalow next door. So again, needed to be fixed and repaired. So for me, I hope that was clear, but I see that as being an issue with availability of information more than anything, and also the program that is attached to it, because again, the position these plots are at in the program, when they were doing the brickwork for that cavity tray to be set out for the bungalows, I suspect that the 33-degree pitch trusses hadn't actually been called off and weren't on site at that point. So again, the bricklayers were using the trusses that were available to them. Okay, moving on to cavities and insulation. 2 relatively common problems, I'm sure. So the first one here is a very obvious one. There's a very big gap in this insulation, which is gonna cause sort of heat loss across there, a nice big cold bridge. So again, not ideal. And then here you can see you've got a gap here, and also a lot of mortar on there on top of the boards. And also it's worth noting that these boards are kind of stepped up. So that for me suggests that somewhere down here or here there's probably some mortar somewhere, because ideally these boards should be the same size, so they should be level. So you go, just an example of what you should do when you've got cavity trays. So the idea is to cut the insulation in front and behind the tray, and that just makes sure that the insulation is continuous, so you've got no sort of cold bridges. And then this second picture here, you can see there's no gaps, all the boards are in line, completely straight. And again, minimal mortar buildup on top of that insulation board. So again, you're going to have no cold spots or anything like that. And they've also maintained a nice cavity. So for me, that largely comes down to a lack of supervision and a lack of quality control, because these things, they're pretty easy to see when you walk around site, and they're pretty easy at the right stage to rectify. So again, just got to make sure that the people who are doing the quality inspections actually have the ability to go out and look, and also make sure that the various trades are supervised. Okay, moving on to cavity barriers and fire stopping now. So we've got a number of different pictures. So these are timber frames, and that first one is a cavity barrier around a door. So essentially what that cavity barrier consists of is a bit of timber wrapped in a damp-proof membrane on the basis that the timber is a certain thickness and it chars at a certain rate, and therefore gives you your level of fire resistance that's required. So the issue for me here is that your timber frame is pretty much straight. Your cavity barrier, essentially your bit of timber wrapped in your plastic bag, is straight, but your brickwork, even within tolerance, not saying that this is within tolerance, is allowed to wander. And also when forming openings, you tend to cut a brick and turn it backwards, so you're going to end up with gaps. So for me, this type of cavity barrier works on paper, but in a site environment, it's not very sympathetic to trades, so it's not the easiest to construct. So again, you've ended up with a large gap there that needs to be rectified. Second one here, again, it's gaps again. Again, different type of cavity barrier, so mineral wool wrapped in a plastic bag. But again, same issue, large gaps, but this is easier to rectify because you can essentially get a large cavity barrier. And then this final picture here, this is more sort of fire stopping. And this is where somebody has seen a large gap and has just seen pretty much a can of what says fire foam, and have decided that because it says fire foam, then pretty much it can just go in that very large gap there, which it probably doesn't actually have the test data to allow it to do that. So what we've seen is people moving away from the timber cavity barrier sort of detail, and a lot of the developers we work with, the timber frame ones anyway, are moving towards a more flexible sort of cavity barrier, which will allow you to use the barrier to take up that tolerance. And then secondly, certainly for us anyway, whenever we do any sort of fire stopping in flats and stuff like that, we'll use a specialist fire stopping company who will come in, take photos before, document every penetration, and then pretty much do the job, provide you with a sticker almost that tells you they've done it, and then also take photos and log some before and afters, so you've got that for your records. And also they are part of a competent person scheme, so you can be more sure that what's being done is correct, for example. So for me, I think that the timber cavity barrier issue, again, I'm sure some people would disagree, but for me, it's an issue of the material. It's not the most sympathetic to people actually using it. It works, yes, it works in theory, it works on a piece of paper, but in a site environment, it probably isn't the easiest detail to construct. And also the second one for me is its contractual arrangements. So what we do, certainly as standard nowadays, is where we've got flats and we've got fire stopping that's needed internally, we will make sure that our employer's requirements state that you need a third-party certified fire stopping company to do that. So again, we've updated our contracts and our employer's requirements to make sure that that's done. And again, that provides us with a greater level of assurance that it's being done correctly. Okay, now moving on to plasterboard. I was going to say you don't really need to kind of look too detailed in order to actually understand what's going on here. So first of all, the board's shot and damaged. Secondly, the main issue is, well, the secondary issue is to do the actual position of the fixings. So they're in the incorrect position, too close to the edge of the board. And then this second picture here is to do with kind of a dab around an opening. So as I'm sure you can see, there's a pretty large gap there. So what should that look like? You can see here that the fixings are nowhere near as close to the edge of the board. So last time I checked, the British Gypsum White Book said that fixings should be a minimum of 13 mil from a cut edge and 10 mil from a bound edge, whereas the ones in the previous picture were a lot closer than that. And then from a sort of plasterboard dab solution, there should be a continuous dab around things like perimeters and various other areas, and the logic behind that is it reduces the air movement behind the board. So for me, what I suspect that is an issue of continuity of trade. Certainly this this board fixing one, because my experience is in speaking to various plasterers, so your package is broken up into the boarders who come in and fix the boards. Certainly your internal sort of partitions, and certainly on timber frame anyway. And then your plasterer comes and he spends more time, or she spends more time than the boarder did fixing it, going around and making sure the boards are fixed correctly. Whereas, just being very cynical on this, it's my view that if you're the one who has to inherit the work in order to get the finish that you need, you probably take more time and care in actually installing those boards in the first place. So for me, I suspect that the issue of the actual fixing and the damage to the boards is more one of the person who's installing them not having to deal with the consequences of that installation. So again, largely continuity of trades. This one is a very interesting one to do with plumbing. So basically this is actually something that was called through, and the resident rang up and said, I've got, this is not Midland Heart, by the way, this is another company. I've got a water leak, and it's showing on my plasterboard boxing. So pretty much the plasterboard was taken off, and it wasn't a water leak at all, as you can probably see from this picture. There's a whole host of stuff that's not water going on there, and there's a lot wrong in this picture, but the bit that I'm kind of picking up is this damage to the soil stack here, and essentially the fact that somebody has decided that a suitable fix for that is to stick some duct tape on it. So basically we opened it up, uncovered that, duct tape all around there, and then you take that tape off and you see that. So that looks like it's either been cut or, I don't know, damaged in some way. And for me, this is an issue of attitude. So pretty much somebody has caused that damage. I don't necessarily know who. And then they've decided that, okay, I've caused this damage, so what am I going to do to fix it? Am I going to flag it up to the relevant people to make sure it's fixed properly? Based on this scenario, no, that has not happened. Instead, what I'm going to do is I'm going to cover it over so somebody can't see it. And then just go on my merry way as if nothing has happened. So for me, that's not the right attitude to have. If something goes wrong, you need to make sure that it's flagged up to whoever it needs to be in order to get it fixed. And for the sake of probably getting a bit of a telling off, you'd have a bit of plumbing that's been installed correctly and is not causing somebody to actually take a property and live in it with those sort of issues. So for me, it all comes down to attitude. Now, electrics, probably not all that common, although it is one of the most amusing pictures I've seen in a while. And also it's very hard to show a picture of a socket not working or a light not coming on. So it's just a more visual example of what's going on. So the picture's not the best, but I'm sure you can see here, you've got your socket there, you've got a granite upstand there, and essentially your socket is too close to the upstand that you can't actually plug anything in. So the initial thought of this is probably, oh God, I've just put the socket in the wrong place. But is that actually the case? Again, don't know the actual details of this, but there's potentially a couple of reasons. So obviously that's what it should look like. You should be able to plug things in your sockets. But for me, this raises a number of different questions. So is this one where home buyers are able to choose from a range of different kitchens? So you kind of your bronze, your silver, your gold, your platinum, and do some of those have granite upstands in them, whereas other ones don't, and just have tiles, for example? Or was a granite upstand an optional extra, which was actually chosen after the electrics were installed? So for me, this is potentially an issue to do with communication, but it could be resolved by just sticking your sockets at a standard height. But that's not necessarily the point for this particular cause. So for me, this could have happened. I'm not saying it has. This could have happened with first fix electrics all being installed, and then a kitchen being chosen too far down the line when it shouldn't have been, and it having an optional extra in it, such as a granite upstand, which meant that when you have installed your sockets with the granite upstand, you can't actually plug it in. So for me, this is potentially an issue to do with communication and responsibility over who needs to tell who and who can decide at what point. I hope that made sense. And then final issue, this is to do with access. So it's one of the ones that we picked up on our site. So this is it's a relatively large builder. It's a standard house type. I will zoom in, don't worry. So pretty much what we've got, I think that works. Yeah, okay. So what we've got here is you've got your kind of, I don't want to call it disabled access, but access for disabled people almost. Around the back there is another access, but you can't actually get into it because there's a step. And it's very interesting. So on the face of it, there's probably not all that much wrong. I'm sure there's a couple of things, but not too much. But when you actually use this in reality, and this was an incidental finding really, because me and the site manager actually stood in the doorway one day talking, pre-COVID obviously, and then he tried to shut the door and he couldn't because I was in the way. So pretty much we were kind of like stood here chatting. So basically, if you look at the kind of standard dimensions of a wheelchair, it's about 1.2 meters long with somebody in it and about 700 mil wide. You stick that through the opening. You can just get it through the opening. But if you're in that wheelchair and you tried to turn it to shut the door, you wouldn't actually be able to shut the door. So pretty much standard house type, gone through all the checks needed, and this wasn't picked up and it made it out onto site. So pretty much the quick and easy solution was that we had to pretty much just rehang the door. But for me, it's sort of a design defect that has kind of gone into a very large builder's standard house types and kind of just followed its way through, been built multiple times and only been picked up because of more of an incidental finding than anything. So again, it just goes to show that designs aren't always right. Now, final set of slides. So gone through problems, gone through underlying causes. Hopefully what I've said so far makes sense to people. There's still 237 of you, so it must be semi-interesting at least. Looking at learning from defects now. So when I was at the University of Reading, we did a lot of work to look at various models and how we could come up with a model of learning from defects. And initially this model was focused on post-completion defects, and it was based upon what various housing associations did and also implemented into a housing association, not Midland Heart, although we do use this version of it. And it was shown that it could actually help them reduce post-completion defects by having various feedback loops. So overly complicated model. So basically what it says is that you need to capture decent defect data during construction from your site inspections, during the defects period, so any defects reported by residents during the defects period, and then any sort of responsive repairs. So responsive repair is something to essentially rectify a defect in a new build property from our sort of asset side of the business. And then what you need to do is you need to analyze that data to identify improvement opportunities. So that could look at the most frequent defects. It could look at the most severe ones from a health and safety perspective. It could look at those that present a potential problem with regards to the sort of cost of repair, so high cost items. Or you could kind of extend it to look at defects that pretty much cause residents to complain and cause them a lot of disruption. So again, that's ultimately up to the end user. And then based upon what you decide to look at based on that analysis, you can go one of two ways. So what you can do is go down more of a formal approach where you look for different options to design out those defects. So are there things you can do? Take the cavity barrier one, which I'll go into in a minute. But are there things you can do to design out that defect? And then once you've come up with those solutions, what you can do is you can codify them as we've put there. Essentially commit them to your employer's requirements. So so they have to be used on all of your builds. And then you continue to analyze that data and then get the feedback from the changes and see if the actual area you were targeting has actually reduced in terms of prevalence, for example, to see if that change has actually worked. The other option is you capture your data, you analyze it, and then you go through sort of a less formal approach. So it could be, for example, taking that cavity tray as an example from the first sort of picture. Could be that you modify your inspection process to make sure that you've got a clerk of works out there whenever a sort of stepped cavity tray is being installed. Or if you see that there are some design defects or potential design solutions, you kind of informally feed those back before you kind of codify them into your changes, if that makes sense. And then you continue to analyze your data as a feedback mechanism to see if the change has been successful. Then the other thing you can do, which is what we're calling the feed forward mechanism. So capture your data, analyze it, and then kind of feed it forward to various people. So we work with a lot of colleges and universities to feed forward information to them to help with their teaching and help with kind of future students and stuff like that coming into the industry. If you notice the standards not particularly clear or could be improved, you could feed that forward to standards institutions. Or if you notice that a product is not working how it should be, again, you can feed that back to manufacturers in order to give them the opportunity to essentially undertake some almost live R&D and improve their product. So just to kind of give you an example of that, we noticed, again, this detail here. Noticed that it was problematic, so that's just an example of it coming in. And then based upon our inspection records, we noticed it was relatively frequent, as you'll see, would have seen from the earlier stats. And again, based on the health and safety nature of it, we decided this is something that needs to be improved. So we fed it forward to a cavity barrier manufacturer who are looking at the potential of developing a purpose-made fire-rated cavity closer for timber frame with an intumescent. Basically, what you got there is you've got almost a standard sort of cavity closer profile, some mineral wool in there, and then you've got an intumescent layer there. So the logic being that during a fire, if there are any gaps in there, say your brickwork's wandered a bit, then that intumescent layer should expand and close off the cavity. So they had prototyped it and tested it, and it did work. But again, COVID and all of that has not been taken much further, but it's still something that's being worked on. But whilst that's being developed, we looked for different options of doing things, and we've decided that this for us is a more sympathetic option. So again, that's what we've done in our design brief. We've suggested that we don't want this detail, and instead we're more happy with that detail. And then what we did is we found that the issue was being reported less. So that suggests to me that initially that this change from this detail here to this detail here has been successful in reducing the number of issues of cavity barriers that we've been picking up. So, and again, it just goes to suggest that potentially this learning from defects model has the potential to work and reduce certain defects in certain areas, whether they're site-based ones, whether they're post-completion ones, or whether they're responsive repairs. So that is me done. That is, as I've said, it was about 50 minutes. So thank you. And if there are any questions, and I'll be happy to answer them. Thanks.
Thank you, Tony. That was great. So I don't know whether you can see the chat and the Q&A.
I can. Let's have a look.
There's quite a few messages in the chat, but a lot of them coming in now are just thank yous.
Okay. Okay. Let's say trawl through the chat, see if I can find anything.
Very busy chat box this morning, which is great to see, actually.
No, that's good. So there's one question here. If all the costs associated with defects you mentioned were added up for one financial year, what would that amount to? Good question. So I said what was about 1.25 million, didn't I? Defects. That's during 8 weeks. Just based on an assumed sort of £100 repair. Again, there's the data's not really there to do it, but you could be looking at during that first 8 week window. Again, it all depends on how contracts are set up, so people might not actually see that cost, but somebody somewhere, whether it's the person who's being called back to actually do it, will feel that cost somehow. You could be looking at during that first 8 week period something like 125 million quid. So again, it's a significant amount of money, but it's one of those things that we really need to look at from a sort of research point of view. We need to look at the cost of quality versus the cost of defects. So we need to quantify the amount of money, as you've suggested, is spent on repairing defects and seeing what that is, and then seeing what we need to do from a quality improvement point of view, whether it is more site inspections and things like that, and the cost of implementing that. And then you need to find the balance between the two, because ultimately, if you say we're spending 125 million quid as an industry repairing defects per year, but it will cost you 250 million, for example, again, just arbitrary figures, to implement some meaningful strategies to actually reduce them, then from a financial perspective, it doesn't make sense. So it's a bit of work that really needs to be done. It's something that I think, to be fair, it's something that I'd be really very interested in looking at. Okay, what other questions have we got?
So there are a few questions for me on the CPD side of things. So if you would like a certificate, please just drop me an email. Email me directly, or you can send it to webinars@cbld.com, and I will be able to get those made up and sent over.
I was going to say some people just saying that Part M non-compliance is a big issue in their experience, and that kind of rings through with what our clerk works are picking up. So yeah, no, agree with that. Again, I think that's relatively it from the question point of view. So I can't see many more.
Okay, brilliant. With that then, I just want to thank you again, Tony, for providing that for us this morning. You've got a lot of feedback coming in, so I will share that with you.
Cool.
If anyone thinks of any other questions or comments or anything in general, just drop me an email. We have the next webinar is on the 16th of March. That is with Eddie Sibley from IMIST. So this was actually meant to be the webinar that was back in November, but unfortunately we've had to reschedule it. So that is now next month on the 16th of March. So please do go and register for that one if it is of interest. Again, just thank you to Tony for joining us this morning. I know he's very busy. Thank you for everyone who has joined as well. Hope you found it informative and beneficial. Any comments or feedback or anything, please do drop me an email, and hopefully I'll see you all online again very soon. And with that, I will close this webinar this morning. Thank you.
Cool, thanks all.